The National Electrical Code does indeed permit the use of the 90°C column for derating ampacities of conductors, but only under specific circumstances. It is crucial to understand these conditions and limitations to ensure compliance and safety. Section 310.15 of the NEC directly addresses the adjustment of ampacities for ambient temperature. This section states that where the ambient temperature of the air surrounding the conductors is between 30°C and 40°C, which is 86°F and 104°F, the allowable ampacity shall be reduced by the percentage indicated in Table 310.15 for the appropriate conductor type. The table provides percentage reduction factors for different types of conductors and insulation ratings. The 90°C column specifically applies to conductors that are rated for a maximum operating temperature of 90°C. It is important to differentiate between the conductor's insulation rating and the terminal temperature rating of the equipment to which the conductor is connected. The lowest temperature rating is what must be used. For example, if you have a conductor with a 90°C insulation rating but it is connected to a breaker or other piece of equipment with a 75°C terminal rating, the 75°C ampacity must be used. Let's consider an example. For a 14 American wire gauge copper conductor with a 90°C insulation rating, you would normally look up its ampacity in Table 310.16 before any derating is applied. However, if the ambient temperature is between 30°C and 40°C, the ampacity must be reduced. Table 310.15 would then be consulted, and if the ambient temperature were in that range, the ampacity would be reduced by the percentage listed. However, there are important exceptions and limitations to the use of the 90°C column. Firstly, the 90°C ampacities can only be used for derating purposes. You cannot use the 90°C column as your starting point if the terminals on your equipment are only rated for 60°C or 75°C. Secondly, the NEC stipulates when you can use the 90°C column. Conductors installed in raceways or cables that are exposed to higher temperatures, such as in attic spaces or unconditioned basements, may be subject to different rules which may preclude the use of the 90°C column. Furthermore, the NEC has specific requirements for conductor sizing based on the termination temperature ratings of the equipment. Typically, equipment is marked with its termination temperature rating, and the conductor ampacity must be selected based on the lowest temperature rating of any connected termination, conductor, or device. Conductors must be protected against overcurrent in accordance with their ampacities. This means that the overcurrent protection device, such as a circuit breaker or fuse, must be sized appropriately to protect the conductor from overload. The NEC provides rules for selecting overcurrent protection devices, including allowing the next highest standard overcurrent device in certain situations, but it's essential to ensure that the conductor is adequately protected. Additionally, it's important to consider voltage drop when sizing conductors, especially for long circuit runs. Excessive voltage drop can lead to inefficient operation of equipment and can even damage sensitive electronics. The NEC provides guidelines for calculating voltage drop and recommends limiting voltage drop to a certain percentage of the supply voltage. Always refer to the specific requirements of the NEC for the applicable article and section to ensure proper application of these rules. The electrical codes are subject to revisions and updates. Consulting the latest edition of the NEC and any local amendments is crucial to staying compliant and ensuring the safety of electrical installations. It is also recommended to consult with a qualified electrical engineer or licensed electrician for guidance on specific applications or situations where the interpretation of the code may be unclear. Remember that safety should always be the top priority when working with electricity. It is essential to follow all applicable codes and regulations and to take necessary precautions to prevent electrical shock and other hazards. Ensure all work is performed by qualified individuals. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, helping to trip over current protection devices and prevent electrical shock. Bonding ensures that all metal parts of an electrical system are at the same potential, reducing the risk of shock. The NEC has specific requirements for grounding and bonding, including the size and type of grounding conductors and bonding jumpers. These requirements must be followed carefully to ensure a safe electrical installation. In addition to grounding and bonding, surge protection is also important for protecting electronic equipment from voltage spikes and surges. Surges can be caused by lightning strikes, power outages, or other disturbances on the electrical system. Surge protective devices, or SPDs, can help to divert surge current away from sensitive equipment, preventing damage. The NEC provides requirements for the installation of SPD, including their location and rating. Regular inspection and maintenance of electrical systems are essential for ensuring their continued safety and reliability. Inspections can help to identify potential problems such as loose connections, damaged wiring, or overloaded circuits. Maintenance tasks such as tightening connections and replacing worn components can help to prevent these problems from escalating into more serious issues. The NEC recommends regular inspection and maintenance of electrical systems, and it's important to keep records of all inspections and maintenance activities. When working on electrical systems, it's essential to use the proper tools and equipment. This includes insulated tools, voltage testers, and personal protective equipment such as gloves and safety glasses. Using the right tools and equipment can help to prevent electrical shock and other injuries. It's also important to inspect tools and equipment regularly to ensure that they are in good working condition. If any tools or equipment are damaged or defective, they should be taken out of service immediately. Proper lockout/tagout procedures are essential for preventing accidental energization of electrical equipment during maintenance or repair. Lockout/tagout involves disconnecting the equipment from its power source and applying a lock and tag to the disconnect switch to prevent it from being turned on accidentally. The NEC requires lockout/tagout procedures to be followed whenever electrical equipment is being worked on. It's important to train employees on proper lockout/tagout procedures and to ensure that they are followed consistently. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. An arc flash is a sudden release of electrical energy that can cause severe burns, blindness, and even death. The NEC requires arc flash hazard assessments to be performed to determine the potential arc flash hazards in electrical systems. Based on the results of the assessment, appropriate personal protective equipment, or PPE, must be worn when working on or near energized equipment. The NEC also provides requirements for arc flash labeling, which must be affixed to electrical equipment to warn workers of the potential arc flash hazard. Electrical safety training is essential for all workers who may be exposed to electrical hazards. Training should cover topics such as electrical safety principles, hazard recognition, lockout/tagout procedures, and the proper use of PPE. The NEC requires employers to provide electrical safety training to their employees, and it's important to ensure that the training is up to date and relevant to the tasks that employees perform. Fire stopping is an important aspect of electrical safety. Fire stopping involves sealing penetrations in fire-rated walls and floors to prevent the spread of fire and smoke. The NEC requires fire stopping to be installed around electrical penetrations, such as conduit and cable trays. It's important to use fire stopping materials that are listed and labeled for the specific application. Proper installation of fire stopping can help to contain a fire and give occupants more time to evacuate safely. Overcurrent protection is a critical safety feature in electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. This helps to prevent overheating and damage to conductors and equipment. The NEC provides requirements for the selection and installation of overcurrent protection devices, including their size and location. It's important to ensure that overcurrent protection devices are properly sized and installed to protect the electrical system from overloads and short circuits. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electrical shock. GFCIs are designed to detect ground faults, which occur when current leaks to ground. When a ground fault is detected, the GFCI quickly interrupts the flow of current, preventing electrical shock. The NEC requires GFCIs to be installed in certain locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electrical shock. It's important to test GFCIs regularly to ensure that they are working properly. Aluminum conductors are commonly used in electrical systems, but they require special considerations. Aluminum conductors have a higher resistance than copper conductors, so they must be sized larger to carry the same amount of current. Aluminum conductors are also more susceptible to corrosion than copper conductors, so they must be installed with corrosion inhibitors. The NEC provides requirements for the installation of aluminum conductors, including their size, termination, and protection against corrosion. It's important to follow these requirements carefully to ensure a safe and reliable electrical installation. Flexible cords and cables are used to connect portable appliances and equipment to electrical outlets. Flexible cords and cables must be protected from damage and strain. The NEC provides requirements for the use of flexible cords and cables, including their type, size, and installation. It's important to use the correct type of flexible cord or cable for the application and to ensure that it is properly supported and protected from damage. Wiring methods refer to the different ways that electrical conductors can be installed. Common wiring methods include conduit, cable, and surface raceway. The NEC provides requirements for the different wiring methods, including their installation, support, and protection. It's important to select the appropriate wiring method for the application and to ensure that it is installed in accordance with the NEC requirements. Electrical boxes are used to enclose electrical connections and devices. Electrical boxes must be properly sized and installed to provide adequate protection for the connections and devices. The NEC provides requirements for the selection and installation of electrical boxes, including the size, type, and location. It's important to use the correct type of electrical box for the application and to ensure that it is properly supported and grounded. Lighting is an essential part of any electrical system. The NEC provides requirements for the installation of lighting fixtures, including their location, support, and wiring. It's important to select lighting fixtures that are appropriate for the application and to ensure that they are installed in accordance with the NEC requirements. Energy efficiency is becoming increasingly important in electrical systems. The NEC provides requirements for energy-efficient lighting, motors, and other equipment. It's important to select energy-efficient products and to install them in accordance with the NEC requirements. Renewable energy systems such as solar photovoltaic, or PV, and wind power are becoming increasingly popular. The NEC provides requirements for the installation of renewable energy systems, including their wiring, grounding, and overcurrent protection. It's important to follow these requirements carefully to ensure a safe and reliable renewable energy system. Standby power systems such as generators and uninterruptible power supplies, or UPSs, provide backup power in the event of a power outage. The NEC provides requirements for the installation of standby power systems, including their wiring, grounding, and overcurrent protection. It's important to follow these requirements carefully to ensure a safe and reliable standby power system. Healthcare facilities have unique electrical requirements to ensure patient safety. The NEC provides specific requirements for electrical systems in healthcare facilities, including isolated power systems, ground fault protection, and emergency power systems. It's important to follow these requirements carefully to ensure patient safety. Industrial facilities also have unique electrical requirements to support their operations. The NEC provides specific requirements for electrical systems in industrial facilities, including hazardous locations, motor control centers, and process control systems. It's important to follow these requirements carefully to ensure the safe and reliable operation of industrial equipment. Special occupancies, such as theaters, assembly halls, and recreational vehicle parks, have unique electrical requirements to ensure safety and accessibility. The NEC provides specific requirements for electrical systems in special occupancies, including emergency lighting, exit signs, and accessible outlets. It's important to follow these requirements carefully to ensure the safety and accessibility of these facilities. Finally, always remember that electrical work can be dangerous. It's important to take all necessary precautions to prevent electrical shock and other hazards. If you're not qualified to perform electrical work, hire a licensed electrician.